Namaste. Hope you're doing well. Today we'll solve the 10th question of ISI MSTAT 2024 PSA, which is a real analysis question. You are given a function which satisfies a certain property, and then there are two statements given about the function. And in the options, you have all possible truthness variety available for the two statements, and you have to select the correct one. So let's get started. Now, before connecting the dots, one thing to go about such questions is to see that when you are given a general family of things, in this case, a general family of functions, could you get to a quick specific example and then evaluate that? In this case, say the simplest of functions is a constant function. Does it satisfy this property? Of course it does, because fx and fy for any different x and y are going to be the same. So this cancels out to be 0. And because x and y are different, this is a positive quantity. 0 is always less than a positive quantity. So the condition is satisfied. So basically, you have an example and then you can evaluate how that example behaves in terms of these two statements. And it's because, think about it, I'm not going to go into detail, but because the nature of the MCQ is in a particular way, if one example from the general family of things is behaving in a certain way, rest of the things in that general family have to behave in that way. So keep that in mind. Now let's get to formal solving in detail. What can we say more about the function? That it's continuous, because this thing is nothing but the analytical definition of continuity. More than that, it's uniform continuity given to us. I'll link the definition in the descriptions, one-liner definitions. You can have a look. Now, what can be quickly asserted about the second statement given to us? Well, that it's true, because if it was false, you would have at least 2 points, because that is the opposite of this statement. Not at most one means at least more than one, so at least 2. You would have at least 2 points, 2 different points where the function, when given input, would give the same value as output. So you have this equal to this. Now, a very obvious thing is written that this thing is greater than equal to itself. Why was this written like this? Because the link over here is that this thing should have been less than this. But because of the assumptions that we made, they are not the way they should be. So it means the assumptions are false. So the assumption that statement 2 is false is incorrect. Hence, the opposite of that is true, which means statement 2 is true. I really like to prove by contradiction. And what can be asserted about statement 1? Well, that intermediate value theorem is going to be of use, particularly because IVT deals with the range of values, the codomain, and how it links with the domain. And we are sort of trying to find a particular point like this in statement 1. So, and because domain and codomain are same in this example, intuitively that will be useful. Now, with this as the basis, let's construct something, a new function. And it's a very important technique. Whenever you're trying to see that your original function is equal to a certain value or not, what you can do is take a difference of these two and define it as a new function. And why is that? Because then your problem really translates to just checking when that new function is equal to 0. I hope you can see where this is going, because if this is 0, fx minus x is 0 and fx is equal to x. So it is analytically and even visually more pleasing perhaps. So now let's investigate certain things about the new function g. When you look at the boundary point, which is f0 minus 0, it is greater than equal to 0 because of the codomain and domain of f. So f cannot take any value less than 0, right? So that's why this. And similarly, about g of 1, this thing follows, that g of 1 is less than or equal to 0. Now another interesting thing, f is continuous, x as an individual function is also continuous. So the difference of two functions, g is continuous, and intermediate value theorem can be used for g, which means that in the range of values that g can take, whenever there is something inside it, you would get a pre-mapping, a point A such that g of A is that value in the range h. With that, I think you know where this is going. You would have 0 in the range of values that g can take because of this thing that we have over here. So this interval formed by these 2 points has to have 0. which means you will have a point in the domain of G, which by the way is same as the domain of F, such that G of A equals to 0. And hence you have this, and you are done. You have that point. Hence you have the answer. Now, some ways to build your base is, there can be two ways to figure out that there are only one identity. Now, remember the example of the constant function given in the beginning of the question? With investigation, it would have been more quickly asserted that these two conditions are satisfied for that function. And provided in exam, you are able to confidently come up with a specific example for a general class of things in a MCQ question, which is similarly phrased, you should use that example and get to the answer quickly, instead of all of this formal stuff. So that's it. And if you like this, then the request is to think about the identity which is most meaningful to you, that one identity. Take care. Hare Krishna.